The objective is to introduce you to the very basics of web security so you can have a sense of the major issues at hand. Outline, so what are some of the things that can go wrong with regard to security, and then what are potential ways to fix these issues. So the structure of this course, I started by introducing a lot of basics of JavaScript, right? We went over the language in quite a bit of detail. And then we're ending with this discussion of web security because I think that both of these topics, both the basics of JavaScript and the basics of web security are something that are so important for people who are doing HCI or design work or engineering work, but it's not really covered in any, formally in any class. Or you might take a really specialized computer security class. So you gotta watch out for the doors. Yeah, door really slams. You might take a really specialized computer security class or cryptography class, or you might take programming language classes and such. But I think that both the things about basics of JavaScript and the things about web security are just good bookends to a class like this. That we're not going to go into a ton of detail, but I think will give you the practical level of knowledge you'll need for building apps. Main caveat is you do not need to implement these sorts of things for your class project because we're pretty much at the end of the quarter in terms of the lectures. And also, you're going to be demoing your projects. These are prototypes you're demoing in front of your TA. You don't necessarily need to deploy them online and such. But you will need to study these concepts for the exam. So all of these concepts in the lecture, we'll have a video about this, will be fair game for exam 2. Main disclaimer, my own training is not in web security, so if you have really, really detailed questions, you should definitely consult the experts. Again, this is not a security class at all. So these lectures are really providing a high-level introduction just to give you a flavor of this. And there have been students who've seen lectures like this and they actually get really interested in security. They're like, oh, I actually may want to pursue this more in future classes or maybe in jobs and such. Because I think it's a really fascinating field. It's something that everybody is affected by. Whenever you're doing software development, or even as a user of software. Okay, so let's get started. So we have 2 parts, problems and then solutions. Let's see if the door is, very nice. No slam on the door. First part is just all laying out problems. So by the end of this first part, this first half of the lecture, you should all be very pessimistic about the state of the world with regard to security. Okay, so let's get started. The underlying principle here that I want you all to take away is that anything that can be faked on the web will be faked. So, any opportunity for something to be faked in any way, it will be, just because there's so many people on the web and trying to exploit it for various ways. So URLs can be faked. So that looks like apple.com. It has a security certificate. It has a HTTPS is security.apple.com. That is in fact not apple.com. The A is not an A. It's a special Unicode character that looks like an A. So that's in fact a fake site. So you can imagine if someone just gave you a URL on the on email or on a message, you click on that site, maybe it looks like Apple, or it looks exactly like Apple. They design it just like Apple. You go and buy something and they just steal your credit card. All right, URLs can be faked. Open source packages can be faked. So those people have used npm, right, for this class to install packages, right? If you're using other languages, basically every language that you're using, there's some kind of open source package manager. So that even for operating systems, right? If you're using something like Linux or Mac, you might use some installer to install a bunch of packages for your development. So npm is what we use for JavaScript. So you might think, someone might tell you, the name for the SQLite driver for Node.js is just SQLite.js. So you say npm install SQLite.js, or someone might tell you, it's Node-SQLite. And both of those seem like reasonable names, right? I mean, they're reasonable names for this. But in fact, these are all malicious packages. These are all bad packages made by people who want to steal your data or something. And this idea is called typo squatting, right? So basically, you just squat it's like squatting domain names. You just squat the names of the packages that are variations or misspellings of popular packages. And if someone just happens to type that in, or someone gets an email, or they just mistype it, right? Oh yeah, Node SQLite. I think it's Node-SQLite. Let's just try it. Then they're going to get one of these fake packages. So this is a really prevalent issue when you're installing packages. So you really want to make sure you spell the thing exactly right. You notice some of these are typos, right? Like there's a extra S or an extra R or something. So if you make you're just typing on the command line really fast, you make a little typo, you don't even notice, and you end up downloading a malicious package. And oftentimes these malicious packages they just use the real package, right? They basically wrap the real package, so it looks like you're interacting with SQLite, but then in the background, it's like stealing all your personal data, all right? Network activity can be faked. So this demo is great for people who are online now. So this is back in one of my college classrooms, way back in the day, many years ago. This is probably actually no. This was taken recently, but I remember when I was in college. This was one of the first times when people actually had laptops in the classroom. So it was very early days of people starting to bring laptops in the classroom. And as much as we'd like to think that everyone is just using the laptops to browse the lecture slides and take notes on it, which everybody here I'm sure is doing, some people end up doing instant message with their friends, or writing emails, or chatting on some chat apps with their friends on these laptops. But these laptops are all going. The internet traffic's all going through these routers here, right, on the ceiling there, and then that's being fed to the school and such. So because of that, because of these routers, if you can access one of these routers, whether you hack into it or you're just a system administrator, right, you just work for the school, anyone with access to the router can read everything, right? Can read your chat messages, your emails, your web browsing activity. Everyone just, and in fact, I remember one of our instructors in college, probably be hard to get really bad press today doing this. He actually printed out some people's messages, like right in front of the class. Like, oh yeah, this is what you all were talking about last period, right? Like right in front of the class. So even worse than reading all your network activity, they can change any network activity, right? So they can just, when you send a message to your friend somewhere, they can just intercept it and change it, and then it looks like you sent some really bad message to your friend, and there's no way for them to know that it's been faked, right? So fake chats, fake emails, fake web pages, fake anything. I mean, you can imagine you're in this classroom, you're browsing to the web somewhere, and someone takes over this router and they make a fake version of apple.com, right? So that everyone here, if you go to apple.com, you're actually seeing the fake Apple, and then you get your credit card stolen or whatever. And it's just because it's just, it's the internet infrastructure you're using. So network activity can be faked. People don't even need access to your router, right? So, there is this is one of the major networks for, internet access in the US, and you can imagine these networks all over the world. If someone just taps into any of these locations, right? Any here, you have, spy movies where someone is, pretending to be a construction worker, and they just like tap into like some line somewhere, and they just read all your traffic, and they can rewrite all your traffic. In theory, anybody on the internet can read everything, right? Chat messages, emails, web browsing activity. And even worse, they can change anything, right? They can change any activity that, that door doesn't actually slam. Good work. No, it's good work. That's good work. You had the magic touch to make it close gently. Clap. Say this to everybody who walks in. So everything can be faked, everything can be changed. And so why is the internet so insecure? Well, it's because when it was first made, there was no security in mind, right? So, this is the ARPANET. This is the early internet, and it's famously connected 4 sites here: University of Utah, SRI, which is up in the Bay Area, UC Santa Barbara, and UCLA. And it was just using the phone network at the time, and there was only 4 people had computers back then at these places, and there was these giant computers, and they had some kind of protocol they made up for them to chat with each other and to send messages. And they didn't need to worry about security at all because there were only 4 of them on the internet, and they were all trusted, right? Like no one else even knew what computers were back then. And then these systems eventually started evolving and growing. So it just started as a way to connect trusted parties, right? And then it connected to the East Coast as well. So this is 1970. It was just 1 year later. It connected across the country to more and more sites, right? So these are major universities, government labs in the Northeast. So this is pretty big that you can communicate across coasts. And then this is 1982. This was, these were the backbones of the internet in the U.S. at least, and these were the major centers. And then it just spread. This is 93, and it's starting to spread worldwide. And now, this is still. Basically, it's all over the world now, right? And it's not just wired; it's all wireless as well, right? Everything is, many countries people are accessing the internet mostly wirelessly through, through these stations and satellites and everything. So it's everywhere, right? But the thing is, it all started from this, right? It all started as a research project that was just connecting people at university labs. Like nobody thought about, nobody in 1969 thought the internet would be used to, power everything that we do, like in our lives, right? It's not just using computers now. All these devices we're using, all these things in our homes are hooked up to the internet. They could have never imagined this 50 or 60 years ago. And then once the internet started getting built, it's very hard to layer security on top of it because you don't want to break the older things. So internet can't be trusted. That's one thing we've established up front because it wasn't designed for trust. Anybody can interfere with traffic and snoop around and change traffic. But users can't be trusted either. Right, so let's assume that the internet is completely secure, right? So assume that we have a completely secure internet with some kind of protocols that were just amazingly secure. You can't fake any data. You can't, steal any data or anything. It's completely secure. Then what happens? So let's say you're creating something like Piazza, right? A discussion forum. So you make a discussion forum. It's a pretty standard app. You have a place for people to put in some data and store it and display it and stuff. Assuming that there's no real bugs in your in the implementation and the operating system and the internet and stuff, what could go wrong? So basically, anytime you see one of these text boxes or anything where users can enter arbitrary data, that's a warning sign. So, and this happens with basically everything, right? So just like I said in the beginning, anything that can be faked on the web will be, or any malicious inputs that you can let people access will be, there will be some malicious inputs. Text boxes are like classic example of this. So anytime you see any app where someone has to enter in information and it's not just from some, fixed set of stuff, that should be like a big warning. That should be a big red flag. And you can't avoid this, right? I mean, basically this is everywhere. So, the intended usage of this is obviously just typing text. Great. You type some text, type some markup, format it. Great. So it's just for plain text. It's just for messaging. That works great. What else can you do with this? So you can imagine, this is not real, obviously. You can imagine typing in some really weird garbled text that does some really weird thing, right? And we'll go into details what this does later. So you can imagine typing a bunch of garbled text that it ends up getting interpreted as code that tricks your database somehow into revealing information such as usernames, passwords, user profiles that this particular user doesn't have permission to access. And the important thing here, this is not a bug in the database itself. The database could work perfectly, but how your app is written just so happens that if you put in some weird strings in some way, and when it queries the database, it causes the database to reveal some information that this user was not supposed to access. So example is, if you're a regular student, you can insert some weird string that lets you view what only administrators or only the instructors can view. Or if you're a regular student, even worse, it can reveal the usernames and passwords of everybody in the class or everybody in Piazza. So this does happen. You can read, I have slides, you can read all about the stuff in the links below. You don't have to be responsible for that knowledge for the exams, but it's just for extra curiosity. Okay, so one thing is you could imagine exposing data from your database. Another thing that you could do is you can imagine writing something and a code in this, something that you write in, it actually exploits a vulnerability, a bug, in your server's programming language interpreter or in your database to take over the server and to do something the attacker wants. So this is, in effect, a bug in your programming language or your database. So it's a bug in Python or a bug in Ruby or PHP or in MySQL or SQLite or whatever. And given some weird inputs, if you make a query or something or you run some code, some weird stuff happens and you can take over the machine. So this might happen. Another thing that might happen is you write something that looks kind of innocuous. It looks like it's just some text. So it looks like it's wrapped in a script. And there's some function that says inject script, steal user cookies, rewrite HTML, whatever. This is all made up. But the idea is, what if you can write something that looks like JavaScript and enclosed by a script tag? The real JavaScript would be really complicated. If you write this in and you store it in your web app, then what happens is this is the post that you made, right, to Piazza. This is what's supposed to do. It's supposed to post what you made. And what happens is when someone else views it, when someone else goes and reads this, this post, when they click on this post and view it, it will pull this up. But instead of just showing literally what this says, it will actually, put this in the HTML of the page. And because HTML, the script by default means JavaScript, it'll start running JavaScript code. And this you can imagine being, this inject script actually can just load some script from elsewhere, right? So your actual payload that you're putting into the site can be tiny because your first statement could just be import a giant piece of JavaScript from another website. And that's doable because web pages can import JavaScript from anywhere. So, and that could just let you run whatever arbitrary code. And this, basically one single malicious user can pollute your whole web app and makes it so that everybody who visits that web app is vulnerable to their browser getting taken over or something bad. So all it takes is one person to write some weird piece of JavaScript, and now all 150 of you, whenever you go to that post, as soon as you click on that post, then some bad JavaScript runs in your browser and it might take over stuff or steal data or whatever. So that means everybody who visits that site is going to see this JavaScript, and it will it'll run. Is there any questions about this? I mean, this is not a great illustration, but the idea that this is not being displayed is literal. This is when you click on this, that HTML is displayed, but that HTML is really telling it to run JavaScript. Questions about this diagram? Yeah?
There's like some funny stuff where you can do type in drop table, so that it actually drops the entire database.
Yeah.
There's a lot of ones that have SQL databases.
Yeah. Yeah, so that is an example of this. This kind of dropping table thing is an example of this. That you write some weird thing, and it's supposed to make a query or something. I mean, I guess this is more likely in a case where you're, creating an account or something, right? So it's like, what's your username, what's your password, and then you can say you can drop the tables. Yeah, so it's an example of this database issue. And the question is, does it affect the NoSQL database, right? And is that SQL, the NoSQL databases might be affected by some weird JavaScript thing you put in, right? Or some other thing, another language you put in. So it's not just the SQL databases are vulnerable to this. All databases can be vulnerable to it. Other questions about this before I move on, or just the concept of this? You don't have to know the gory details. Right, so the basic idea is one person puts some weird JavaScript in where you're supposed to just put text, and then when everyone else visits it, they run this JavaScript, and that does something funny. Okay, so this is bad, obviously, because the users, all of you who are just regular users of Piazza, they trust this web app, right? They trust the app to not do something bad. But even if the web app creators are honest, right? It's not that Piazza made some bad thing, right? It's not that Piazza or your version of Piazza had some bad, was malicious. It's that some other users are malicious. Some other users aren't honest, and they've injected this into a forum or a chat room or something, and then now everyone else suffers. So even if you're perfectly honest as the creator of the app, you have to defend against people who may not be so honest. And as the number of users you have goes up, the chances of one person, right? You just need one person to do something bad, goes up to probably 100%, right? When you have enough users. If you're careful with details, it's called a cross-site scripting attack. I think it's a really confusing name. Basically, it just means that these kinds of attacks are caused by the fact that the web app is not validating or sanitizing the data before displaying them to other users. So we'll go into solutions in 1 minute. But basically, the underlying issue behind these attacks, don't worry about the name, is that when you're displaying the information to all the other users, it's not filtering it. So the way to filter this is to actually display it literally as these characters. But if it's not filtering it, it just interprets it as a piece of JavaScript code. Okay, so now on to some potential solutions. So hopefully we'll have some, happier news. I think this is practical for everybody, right? So this is web security tips for everyday users. So you should, tell everybody these things. So you're going to websites and it could be a fake domain. So the biggest thing is to use a reputable web browser, right? So we do have to trust our web browsers that we use because we're using them, for pretty much everything nowadays. And you probably want to use one that a lot of other people are using, and maybe not one that you just found randomly that seems really neat because no one else has used it or read it. Keep it updated to latest security fixes and also safety features. So modern browsers like Chrome and others, they have they always keep a vulnerability list of these domains seem like they might be fake, or this might actually have some weird. I mean, I think after I'm sure this wave of vulnerabilities was disclosed. I'm hoping that modern browsers will warn you that this character is not really an A, right? And they always keep up to date a list of warnings of websites that might be bad or weird characters or such. And in fact, I think Google Chrome and other apps, they pioneered this model. I mean, now we take it all for granted, but I think when Chrome came out about 10 years ago, it was really controversial that they forced you to upgrade your browser. And now no one even bats an eye because everything is upgraded automatically in the background. But back then, in the old days before Chrome, it was really controversial to force users to update because users are like, I didn't want to change anything. I'm happy using my own web browser right now. I want to opt into updating. But something like Chrome is like, no, we can't. The opt-in model is just not going to work because most people are not going to opt in to updating because people are just have inertia. So we're just going to force these updates behind the scenes. And by doing that, we're hoping that the web is more secure because whenever they find security problems, they can push that into their browser. And now it's much more of a regular occurrence. Another thing is manually type in the URLs and then bookmark your own URLs. That's, hopefully your keyboard has not been taken over by anything weird. So typing in stuff and also hopefully you don't make any typos, right? So another big use of malicious sites is people's typos, right? You can typo squat these too. So if you type in some long URL and it's a little bit wrong, you don't have a dash, it can go to malicious sites. So type in your URLs and bookmark them. And then back up data somewhere, right? So just back up your data somewhere off-site. So that in case something bad happens to your computer, this is not just security problems. This is if you lose it, it falls or whatever, you have it somewhere else. Like you all have Google Drive accounts through UCSD, you can all sign up for other accounts as well, just like back up your data. Because sometimes if you get a virus on your computer, then you might get something called ransomware, which it actually just encrypts all your computer's files, and then you have to pay somebody something in order for it to decrypt it. So essentially it's deleted all your files. So, just don't assume that the stuff on your computer will last because something might, go wrong somewhere or other. And then encrypt important files and passwords. So use a good password manager, encrypt things that are important and such. Also, this is general life advice now. Monitor your credit card bills every month, your bank accounts, and also you can get free credit reports every year. You can get, I think, one from every major credit reporting agency. Just make it a habit to do this every month or every few months because, in the end, a lot of times these sorts of security issues, at the end, what people are after is money for the most part, right? So unless you're someone who's, working in some company that has top secret, information on your laptop, if you're just an ordinary person, just an ordinary citizen, most likely the failure mode for these, success, I guess, for these attacks, most likely what you'll be targeted for would be something related to money. And identity theft is a part of that, right? So the point is that if they steal your identity with information, they can use it to open bank accounts, ruin your credit, take out loans or whatever. So I think that in the very end, if you want to defend against everything, no matter what you do here, if you just monitor your finances, that's basically in the end what it comes down to. Pretty much for normal people, making a habit to monitor your finances to make sure everything is good. You can also get this is actually a recent thing because we've had all these security breaches, right? I mean, you hear every few months there's some big company that's had all their data, customer data stolen. It's gotten more popular to do what's called freezing your credit. So basically what you can do is you can, I think online, or you can just send an email. You can just freeze your credit from the major credit reporting agencies, which means that nobody can actually open new accounts and do that stuff. So it's actually really good to freeze your credit. And then you need to unfreeze it whenever you take out a big loan for school or for a house or a car or something. But by default, if you lock everything, it's great because then if something weird tries to happen, it's fine. So freezing your credit should be a thing to add on there. Okay. With that out of the way, basically, I just emphasize this thing in red. Just monitor your own finances because even if you keep all of your own data safe, right? Even if you do all this stuff and you're the best security person on your computer, you lock your computer up and everything, in the end, your data is everywhere in other people's computers. So, Equifax is one of the big credit reporting agencies, right? That's an agency that people trusted with their financial information and to report their credit. And they had this, famously had this big data breach a while back. And, and our data is just everywhere. Target has a huge data breach. Every big company you've seen whom you've done online shopping with probably has some data breach sometime, right? So, in the end, again, just make sure to monitor all of your own stuff and your own family's things. Okay, so for developers, so that was for users, right? That's like useful for everybody. But what do you do if you're a software developer? So if you're a software developer, a big one is, again, just like the last lecture, look for reputable things, reputable tools, libraries, well-maintained organizations, who they have their own reputations on the line, right? So if something is sponsored by somebody that you trust, then there's this chain of trust, right? It's their reputations on the line if something goes wrong. So you would hope that if they have a good reputation with security, that they would find problems and solve them. Make sure you spell everything correctly. Again, this is very, very common for it's just like typing in URLs, just spell everything correctly. Also, Google, just search for things, right? So if you think Node SQL or whatever is the right one, just search for Node SQL NPM, and then I'm sure you'll find the top pages like, well, this is like a majorly bad thing. Okay, another thing here for security is don't write your own stuff, right? Don't write your own login authentication, cryptography, anything that has to do with security authentication. For a class project, for a prototype, it's fine to play with some of this stuff just because it's, it's good exercise. But when you're doing it in production, you should never write any of your own things for anything that's mission critical. You should rely on widely used, well-maintained libraries, again, reputable organizations. Just don't write any of this stuff from scratch. Just because this stuff is, is highly targeted, and the more people that are looking at it and fixing bugs, the better. If you try to write your own, I'm sure there are cases that you didn't account for that the people in these widely used libraries accounted for. And it's also easier that way, right? Because you don't have to write all your own code. Okay, so with fake network activities, the issue with this, has largely been solved nowadays with HTTPS, right? So nowadays, many sites and apps are using the secure version of HTTP. So which means that unless something catastrophic happens, for the most part, your data going through gets encrypted on your computer, and then it's being sent through encrypted in most places. So this solves a pretty big swath of the issue. So back in the days when I was in college, when basically nobody used HTTPS, it was just a wide open field. I remember when I was in college, not only in lecture halls do you just see everybody's stuff, right? You can just see everybody's stuff. That means someone needs to have access to the router. You need to the instructor has to contact the system administrator or whatever. But I remember in our dorms. So like in our dorms, how the internet worked was that everyone was just connected on a wire, right? Everyone just had wired internet. And how Ethernet works, if you take a networking class, how Ethernet works is that imagine you have, 100 people on your floor, or however many people on your floor. How actually Ethernet works is when someone, let's say you're chatting with someone, right? You're chatting with someone across the country. When their network packets, when their chats get into your dorm and they go into your floor and stuff, believe it or not, everybody sees that data. It just gets broadcast. That's how Ethernet. It just gets broadcast to everybody on your floor. But it so happens that only your network card picks up that traffic. Everybody else's network card sees that, but it sees that's not meant for them. It's not meant for their computer's IP address, so they ignore it. So everybody on your floor, or whatever your router is, sees all the traffic technically. And back then, everything was unencrypted. So it was trivially easy. You just install a program in your computer and it just turns your network card to read everything. So basically everybody could see everybody's information. Like that was like a widely known thing. Like whatever you're doing on the internet, everybody could see. Like this was like a known thing in college. So maybe it was a deterrent against people doing shady things. Or maybe not, because that was also the era where file sharing really started on college campuses, and because people didn't have HTTPS, college students were actually arrested and sued for file sharing back in the days. That was like the first wave of file sharing stuff. So yeah, this is all real. Everything was unencrypted. Everything was just out in the open. But now now it's a lot better. Now you can feel free to do stuff with the protection of HTTPS. So HTTPS has solved a lot of things. And many sites, if you're hosting your web page on GitHub, if you're hosting your personal web page on GitHub, which that's a good place to host because it's free, and also it gives you the certificates for HTTPS. It comes by default, so that's really good. Other services you can probably subscribe to, you can pay for, just handle all of this for you. The technology that underlies this, public key cryptography, is I would say one of the most important contributions to the whole internet, besides the internet itself, which also won a Turing Award, which is the highest prize in computer science. So the team that did HTTPS got their Turing Award in 2002, which is, that was quite a while after the internet was invented, right? So it was 50 years after the internet was invented that people started thinking about security. So, without public key cryptography and HTTPS, we just would not be able to function today. I mean, you cannot imagine how people would do any kind of banking or shopping or anything over the internet without HTTPS. Easiest way, again, is to host your site on a service. So GitHub's a great one. It's free. You just host your site on there. It's all HTTPS. It's getting easier now. There's this thing called Let's Encrypt that's being hooked up with a lot of web hosting services. That makes it much easier for you to do HTTPS today. It's still not trivial to do. They're still trying to push it to make it easier. But so if you want to host your own, you can use a site like this. OK, so final part is the following. So HTTPS doesn't cure all of your problems there, right? So this is the hypothetical future where the internet becomes kind of secure, right? So it's a lot more secure than before, where everyone can read everyone's network traffic. It still might have bugs and issues and stuff, but let's pretend like this is, if we all have HTTPS, let's pretend like that makes the internet reasonably secure. So now that we have largely achieved the dream of a secure internet, you still need to defend against malicious users, right? And that's not going away anytime soon. We'll never have an algorithm that defends against bad people. So the general rule, again, is that anytime users can send any input in your web app, you have to really pay close attention to the parts of your code to handle these untrusted user inputs. You should imagine that anytime anyone can enter anything in a text box or fill in anything, that somebody's going to try to push the envelope and send in something really bad, just at any time. So internet can enter, neither can users. OK, so let's go back to our example before. So let's find some solutions. Again, this is injection. This is injection from the database. So how do we defend against database attacks like this? So here's some high-level solutions. So don't create your own database queries manually. So this is the example you mentioned with the dropping tables. So if the simple thing to imagine making a database query, especially in these SQL-like languages, is just to put a bunch of strings together, right? Just say select and then plus and then the name of the person plus whatever thing. You're just making a big query because after all, SQL is just a giant string that you're passing in. And that leads to a lot of bugs because people can write weird punctuation to make it break into multiple statements and such. So instead of never just combine strings and make your own database queries, always use the APIs and follow the best practice from those APIs. So any API you use for a reputable database will include functions that sanitize or clean the input, and just follow them. It might seem kind of bulky. You might be like, oh, I'm just going to write this query and just pass it in. Just never make database queries yourself. Always use their APIs. And their APIs are hopefully tested and well vetted and such. So the underlying thing behind all this security stuff is really just use people's APIs and hope that they're, they have good reputations. There's not really any more science to it. OK, code-based attacks. So this is an attack on your database. There's not a bug in the database. It's just that the database is doing what you told it to do. It just so happens that someone has tricked you into telling the database to do something bad. Now, this is when there's actually a bug, right? There's a bug in Python. There's a bug in Node.js. There's a bug in PHP. There's a bug in the database itself. The way to deal with this is to keep the operating system of the server and all the relevant apps updated, especially with security patches and security bugs. This can be a big pain, right? Because your app might be running, several different languages and different databases. Your operating system, to power your web app might require, 50 things or maybe 100 things, and those things depend on stuff. So then you have to always keep them up to date, right? Every month you have to check to make sure to get the latest version of every single library and every single application and keep it up to date. And the scary thing is when you upgrade, maybe sometimes when you upgrade, something else changes in their code. That breaks your own code, right? So remember, this is a long time ago saying, if you never upgrade and you just keep your server the same, it's good in quote unquote in the sense that your stuff will keep working, right? Things keep working. If you upgrade, it could be quote unquote bad because something might break and you might have to change your code. But it's good also because it picks up the latest security issues. So if you have a team with system administrators or DevOps people, this is their job to do this. Like imagine if you're at any company, just the sheer complexity of how much software they depend on, the operating system they depend on. They have people whose entire jobs it is to keep all of those things up to date with latest security things. And you can't just hope to do this yourself. It's just way too much. Okay, cross-site scripting attacks. This is the last category. So to defend against some of these attacks, the general principle here is that before displaying any output to the web page, you need to escape the special HTML characters so that they display literally as strings instead of getting executed as JavaScript code. So for example, if someone puts some weird JavaScript code in here, and then what we do is, this is bad, right? Because this will actually run the JavaScript. What we do is we rewrite it into something like this. So when the code that you have to display whatever someone put in, whenever there is a less than sign, we're going to use ampersand LT semicolon, and when there's a greater than sign, we're going to use ampersand GT semicolon. So this, if we display this HTML, literally, if you paste this into a web page, that will literally display as the less than and greater than. Like, this, if you put in this in your HTML, it will literally display as that, and it will not run any JavaScript. Nothing here says to run JavaScript, right? But if somebody sees this HTML, the starting script tag means go switch to the JavaScript interpreter and start running JavaScript from here. And this means, just display this ampersand LT, and then HTML knows that ampersand LT is the less than sign and such. And this happens not just in HTML, but in many, many other languages. So like, in other document formats, when they start becoming sufficiently complicated that you can execute code, you're vulnerable to these vulnerabilities. So now everybody who visits your site will literally see the content of the code and not doesn't run the JavaScript itself. So there are questions about this, how it looks different than the other one? And that's hard to illustrate without actually having code. But this defends against most of these injection attacks. And there's this great web page. You don't have to know all this stuff on the web page, but this is a great web page that actually shows you really concisely several different major kinds of attacks. And cross-site scripting is like the most common one. And it actually tells you exactly what to do in order to defend against it. And the rules are actually pretty complicated, but the big one here is HTML escape before inserting interested data, HTML elements. So those are the things to escape: ampersands, less than, greater than, double quotes, single quotes, and slashes. And there are some other rules as well for what else you need to put them. You don't have to know about the details, but basically this organization has really curated very detailed guidelines for what to do. And they have to constantly update it, because if a new browser comes out or a new version of HTML comes out, there's just going to be new weird tags that come about. So it's a never-ending quest to keep these things updated. But this OWASP website is pretty good if you're curious about checking out their cheat sheets. Okay, so that was it for the web security lecture. The basic idea here, again, is just to show you the really basics and just kind of see the issues at play that, basically don't trust anything on the internet. And when you're making these applications for real, you should really think about these things. And the hope is that if you're in an organization that has resources and cares with security, you're going to be able to work with people for that. And the other, the other end of this is that if you're interested in doing web security stuff or just security in general, I think that you will always have a job. So for people who really have an interest in, if this sort of stuff kind of piques your interest and you want to study this more in the future, I don't imagine this ever going away, right? Because for as long as people exist, they're going to find ways to exploit systems, whether it's on the web or whether in the future we're all going to be in VR or in space or whatever. Whatever platform we're using to exchange information, there's going to be bad people who want to exploit it, and there's going to be a need for security research to be able to counteract that.